and that has to be matched, that has to be plotted on the ROM and RAM. What is the difference between ROM and RAM? RAM plots the data picked up and ROM has got some inherent data impregnated or printed on that. That has to be matched, then only you can deliver this thing. Now comes termination. This is a very boring lecture. Why? Because the same terminology, four terminologies cyclically coming and going. The termination of the inspirative phase. Classically, when we are student of critical care or anesthesia house terms, my teachers, they used to taught the patient in only this part. The pressure cycle, volume cycle, time cycle, flow cycle. But nowadays classification is more elaborated. Actually, these are the termination of the phase termination of inspirative process of a machine. But initially it was thought that it was the beginning of the respiration. The termination, pressure cycle, already you learned, volume cycle, time cycle, and flow cycle. When a set target is achieved, it will terminate it. There are many more varieties. I don't want to confuse you all these things. There are the CMB, access control device, IMB, intermittent monitoring. I will show you how it works. These all will come gradually. Now, look at the curves. This is a classical control. That means pure and simple mechanical pressure. No relation with the patient characteristic or anything or whatever. Means what I have said, patient will get. There are two curves, one for the pressure, one for flow. Initiation, that means the inspiration has started, machine start delivering, the pressure is gradually reaching to a target. And cycling, the end of the respiration, it suddenly drops because there is no airflow from the machine side, so there is a drop in pressure, it goes down, and then there is a gap. Gap may be in between, it is an exhalation process, or may be combined with pause. Say for your understanding, it is better. This is an inspiration, this is an expiration, pure expiration. So this air has gone to a patient lung. It has to come. It has to come. How will you know? From this pressure curve, it is very difficult to understand about the exhalation part. Now you need a flow sensor. This gas has gone up to this level, sustained in the lung. Now this, here is a blank. If you have a flow sensor, immediately you can see this air is coming out of the patient lung and gradually velocity is decreasing. Initial velocity is very high because of it follows the starting slope. There, if stretching is more, the contraction will be more. So initial velocity is very high, but gradually it's declining to zero state. And see, there is no gas flow. This is the pause. Here you cannot understand whether there is a pause or anything from the pressure curve. But when from the flow curve, now another thing. From pressure curve, it shows like a sinusoidal, but actually patient is getting here a square wave flow pattern. Because of high velocity of flow, it goes like this. Then maintenance of the entire pressure, the peak pressure is maintained here. So it is a square of curve. So you need to look at both the curves, the pressure and flow at a time. Then only you can understand what is happening. But if your machine doesn't have the display arrangement, you have to be very careful in the clinic. The mimicom of his hand, then application of the stethoscope, looking at the patient chest wall, but it requires some training. of the safety is needed for this control device because it is a very unintelligent mode of ventilation. The control mode should never be deliberately set as the ventilator should never be insensitive to a patient breathing. So the classical ventilatory feature has been industry standard. Now it become industry standard that most of the sophisticated manufacturers, they have abandoned this classical control system because of, you can understand by this time that you miss the patient lung because nothing variable, only my quiz. If I am a very bad clinician, I can damage the lung. So control ventilation in a patient-driven function, and new ventilators do not even incorporate a pure control function. They incorporate a lot of things in it. Now comes what they incorporate. They incorporate assist or assist control. Because pure control hardly will get exception for anesthesia ventilation or for patient. The role are very fixed. The patient is able to trigger and start of the respiration. Now look at this respiration. This is same with the previous one. But what are the difference? There is a notch here. See, there is a notch. That means patient has started taking inspiration. So pressure has gone negative. These will switch the machine in on position. This will act as a switch off. Now flow starts. If you look at the flow, this red part is patient generated flow rate and then sensed by the machine and simultaneously in coordinates of the patient respiration, machine starts delivery. So what is the difference with the earlier one and this one? There is no notch, no velocity. It is absolutely machine dependent. Here, the patient effort has been identified by the machine and machine starts and with the patient own inspiration. Where that we already learned, it may be patient pressure triggered, it may be flow triggered, whatever may be the trigger mechanism, but basically the assist control works like this. Now, more details. Ventilator delivers what it does, it gives a fixed quality. Control mode. Patient receives a set number of breaths and cannot breathe in between ventilators, single end breath. This is a control mode. This is negative side, this is positive side. This air goes in, already you have seen this curve, like that. Assist control mode. See, there is notch. The machine is started by the patient on the inspirated device. It is of course a pressure triggering. It starts at say, if it is a -3, that means it is a 0.5 centimeter. Even if a 0.5 centimeter can be sensed by a patient, slightest flicker will initiate a machine to the inspirating phase. Then comes other parameters, which slide I have skipped very rapidly. IMV. What is that? Intermittent mandatory ventilation. Now think about me. I am a 60 kg person. Okay, don't believe my talk. I am not 60 kg. But for calculation purpose, I am thinking that I am 60 kg person. What will be my ideal minute volume? 6 liter. Now I am to tell my machine that I will be on ventilator. My mandate volume is 6 liter. That mandate has to be given to the patient that this patient will require 6 liter per minute by any chance. See, now I have taken huge alcohol in my conference, or whether I have spent me a bottle of whiskey, I get half drunk. My tidal has fallen down to 3 liters per minute. need a ventilator. So what to do? My lungs are okay. My demands are all met. Only because of the narcotics influence, my tidal has fallen down to 50%. So when I will be put on ventilator, the machine will work as a watchdog. Basically, machine will work as a watchdog because the machine has got a flow sensor, machine has got all varieties of gadgets. They will monitor how I am breathing. Say by any chance, if my all friends, those who have fed me, they are around me, I am aroused, I can take 6 liter breath on my own. Machine will not take or deliver any single delivery of the air. Because machine is monitoring only whether I am able to generate 6 liters or not. Now they have gone back, I again fall into sleep and an influence of the narcotics, gradually my tidal are falling. What will happen? Now machine will watch. Still the machine will allow me through the ventilator circuit, machine will only deliver the atmosphere because the machine has got the blender inside. You have seen in the first slide, blender inside. If I have 0.21 is enough, I don't require much oxygen. So room air is enough for that. The 0.21 FiO2 air is delivered by the machine. I am taking respiration to the respiratory circuit. From one side the air is coming to me and it's going on. Now gradually it is declining. The watchdog now become alert. See to this car. This is a normal, the dust curve is a normal respiration. Normally, say this is my normal requirement. 1, 2, 3, 4, 5. 5 breaths in this scale is required. Now machine has assessed that I can generate only 1, 2, 3. This dashed curve is generated by patient, means me. I have generated only 1, the full cycle, 2 full cycle and 3 full cycle. The shortfall of 2. That will be delivered by the machine. This is machine delivery. This is IMD. Say I have generated 4, shortfall of 2 liters has been given by in between mechanical breath. Okay? Now again look at this curve. When this mechanical breath has been delivered, here, what is this phase? This is actually exhalation phase. That means I am exhaling some air and machine is delivering in me. So there will be fighting between my exhalation and mechanical delivery of the breath. Now there will be clash. So IMB is not good for me. Till now I am advocating for IMB. Now I am telling IMB is not good for me. Okay. Why? Because it is not sensing my respiration. So comes SIMB. The same mandatory breath will be delivered when I have started taking the next breath. It will sense and it will deliver. Basically both are same, IMB and SIMB. Only this is asynchronous, this is synchronous. When I have initiated a small breath, machine is supporting my respiratory drive. So the 6 liter is delivered. I am set. Is it clear? Any question? Safety issues? The control rate must be set high enough to ensure the minute ventilator will be adequate. So you have to be intelligent, you have to be thinking. Most of the time we don't take the body of the patient. Of course you have to assess because most of the critical care patient, None of the hospital in Calcutta excepting one hospital have the bed weighing machine. So you have to assess, looking at the patient, how much is his body weight, you set the ventilator level. Then apnea ventilation will also serve as a backup. And most of the ventilator nowadays, if you do a wrong calculation or wrong setup, the software will take up the issue. Nowadays intelligent ventilators are coming. You put the endotracheal tube size, you put the body weight to the machine, immediately they will calculate and they will do the basic job for you. Because of the nowadays the softwares are very intelligent. This is only mathematics. The rate increase expiry time will shorten and gas tapping may fall. This is another important. I will go into the detail auto. This is known as auto feed. I will tell you in details of this because it is a very important feature for any ventilator. The stagnation of air. If you don't give enough time to exhale out, what will happen? There will be pent up of air and gradually lung will inflate, a time will come when it will burst. I will tell you later about this auto breath generation. This is SIMB, already I have described. What are the advantages of the SIMB? Synchronized breath may improve patient comfort, increase patient control and regulation, enhance blood flow. Why? Why patient blood flow in SIMB? কে বলবে? আরে কিছু উত্তর না দিলে একা আমি বকে যাবো কতক্ষণ, আমার তো গলা ঠিক আছে। হ্যাঁ?
Patient muscles is also working because it's assisting the respiration. Synchronized assisting the respiration. So patient was it's not totally control the respiration. It's not totally controlling the respiration.
ये बोलले बाबा डीएनबी पास করবে না বাবা। অন্তত এমডি পাস করে যাবে। ডিএনবি এক্সামিনার দেখাতে বললে
Negative intrathoracic pressure will be there. Negative intrathoracic pressure will be there.
Very good. Then what will be the result? And ultimately examiner will ask you.
Increased cardiac output will be there. Increased cardiac output.
Increased cardiac output. I tell you in the very beginning. That is the all unscientific job we are doing, excepting the Quirous ventilation. But here the natural respiration is maintained. So third rate is working. Very colloquial language. So cardiac output is hyperventilation, less of concern compared to assistance. This is already told. I'm not going into the details.